All right, let's jump right into this explainer. Today, we are tackling something that is absolutely fundamental for anyone doing research, investigations, or cybersecurity work. We're going to learn how to build what is essentially a digital DNA forensics lab. You see, whether you're tracking down online threats, looking into a fraud case, or just doing some really deep dive research, the environment you work in, it's just as important as the tools you use. The key concept we're going to keep coming back to is OPSEC, operational security, and making sure your own digital footprint doesn't completely ruin your hard work.
There's a brilliant quote from our source material that really hits the nail on the head here. It says, much like a DNA forensics lab must be configured and ready, we should begin each investigation with confidence, knowing we're working within an environment without any contamination. I love that comparison. It's so powerful because everyday digital traces, your personal login cookies, your browsing history, your real IP address, those can literally fatally contaminate your evidence. If you cross-contaminate your personal everyday life with your target investigation, you are setting yourself up for failure right out of the gate.
So let's lay the groundwork. What exactly is OSINT? Well, open source intelligence is any and all information obtained from overt collection. That includes things like public records, media, and of course, the internet. But I really want to stress that word overt. We're not hacking, we aren't breaking into private systems or bypassing passwords. We are systematically and securely collecting data that is already publicly available. We're just doing it in a highly professional manner. Here is our game plan for today. We're going to build this lab layer by layer so it isn't overwhelming. We'll cover legal and ethical rules, hardware setup, virtual machines, essential tools, and finally, how to properly preserve your evidence. Starting off with layer 1 of our blueprint, legal and ethical rules. Before we even think about touching a keyboard, we have to understand our boundaries. The crucial takeaway here is that there are non-negotiable legal frameworks you absolutely have to operate within. You've got to respect data privacy laws, like GDPR when you're handling personal information. You need to respect copyright and intellectual property. You also really need to pay attention to a website's terms of service. If a platform explicitly says no automated scraping, well, you need to understand the legal risks if you decide to ignore that. And this should go without saying, but you must avoid any activity that crosses the line into cybercrime, like trying to access closed networks without authorization. But honestly, it goes beyond just staying out of jail. There's a strong ethical duty here. Always minimize harm. Just because a piece of information is public doesn't mean it should be weaponized. We have a real responsibility to adhere to ethical research guidelines and respect people's privacy rights. Your lab should be a precision tool for gathering intelligence responsibly, not a weapon for harassment. Okay, with the ground rules established, let's talk about the physical foundation of your lab, hardware and workspace setup. I want you to think about the computer sitting in front of you right now. If you're going to be querying massive data sets, like massive dumps of leaked breach data, hardware speed is literally everything. Our sources contrast this beautifully. An NVMe solid-state drive can hit read and write speeds of up to 7,000 megabytes per second. Now compare that to a traditional spinning disk hard drive, which chugs along at just 135 megabytes per second. To put that into perspective, when you're sifting through hundreds of gigabytes of raw text, that speed difference is the deciding factor between a query taking a few seconds or grinding on for several grueling days. Because of this, modern M-series Macs or Linux machines with NVMe drives are highly recommended for the heavy lifting. But here is the absolute golden rule of hardware OPSEC. Never, ever use your primary personal computer for data collection or investigations. Seriously. Mixing your personal banking, your family emails, or your work logins with shady breach data and malware-ridden websites, that is a complete recipe for disaster. You need a dedicated machine or at the very least a strictly separated environment. Which brings us perfectly to our next layer, virtual machines and isolation. Because, let's be real, buying a brand new physical computer for every single investigation just isn't practical. Let's cut through the jargon for a second and clearly separate these two environments. You have your host operating system, that's the physical laptop or desktop you're actually touching. Then you have the guest operating system. This is a totally independent system running virtually, entirely inside the host machine. This guest system is what we call a virtual machine, or a VM. It is literally a computer within a computer. Going back to our earlier metaphor, a VM acts as a digital hazmat suit for your host system. Whatever happens inside that VM, whether you accidentally click a malicious link or download a highly suspicious file, it stays completely trapped inside the VM. Your main host system remains entirely isolated and totally safe. Setting this up is actually a lot simpler than you might think. Step 1, you install VM software, like UTM for Mac or VirtualBox for Windows and Linux. Step 2, you install your investigative operating system inside that software. And step 3, and please don't skip this, you create a snapshot of the clean state. A snapshot is basically a time machine. It freezes that perfect untouched moment in time, so the second your investigation is done, you can instantly revert back to it, entirely wiping away any traces of your work.
So, what operating system should you actually run inside this VM? The sources strongly recommend Linux distributions, mostly because they're incredibly fast, lightweight, and they actually respect your privacy. Pop-OS and Ubuntu are fantastic for general research. Kali Linux is your go-to if you need specialized cybersecurity tools, and Tails OS is what you want for maximum anonymity. You'll notice Windows is heavily advised against for a host machine because of major privacy and telemetry concerns, though you can totally run it as a guest VM if you have a specific tool that absolutely requires it.
All right, now that we have our isolated virtual machine built and running smoothly, let's talk about essential tools and extensions. It's time to stock our lab. So where do you even start looking for data? The OSINT framework is an incredibly cool interactive roadmap. When you have a single piece of data, say just an email address, a username, or an IP, you click through this massive tree, and it maps out exactly which public resources and tools you can use to track down that digital footprint. It's absolutely the ultimate starting point for finding public data.
Let's look at a few powerhouse tools you're definitely going to be using. Shodan is essentially a search engine, but for connected devices. It lets you see what hardware an organization has left exposed to the open internet. The Wayback Machine is a classic. It lets you explore archived and deleted web pages, because as we all know, the internet never really forgets. Have I Been Pawned is absolutely essential for checking if an email or an account has been compromised in any known data breaches. And Maltego, that's a visual link analysis tool. It's amazing for mapping out complex, spiderweb relationships between domains, IP addresses, and people. But here's the thing. Finding the data is only half the battle. Hiding your own tracks is the other half. Your browser needs specific extensions to mask your digital fingerprint. You should definitely be running a solid ad and tracker blocker, like uBlock Origin. Firefox multi-account containers are amazing for keeping different research identities strictly separated from each other. Location Guard is great because it prevents websites from tracking your true physical location. And a user agent switcher can actually trick websites into thinking you're browsing from a completely different device or operating system altogether. Okay, we've built the lab, we've isolated it, and we've stocked it with our tools. Now for the final phase of the blueprint, preserving evidence and clones. This is all about wrapping up your case safely, legally, and ensuring the integrity of your findings. Our source material outlines a very specific, rock-solid workflow for this. When an investigation is over, you do not just close your browser window. First, you shut down the investigation VM entirely. Second, you export that entire VM to a single file. And third, you store that file on an external encrypted drive. Doing this ensures you have a frozen, uncontaminated, perfectly preserved record of your exact investigative environment, exactly as it was the moment you found the evidence. Now, why is this so important? Well, consider this fascinating real-world story from our author. They were testifying in court, and the defense actually demanded full access to their investigative computer for scrutiny. Because the investigator had used a dedicated VM, they were able to convince the judge to only hand over the 4-gigabyte cloned VM file rather than cloning their entire hard drive, which, by the way, contained highly sensitive data for totally unrelated active cases. It perfectly protected their other investigations while fully satisfying the court's requirement for evidence discovery. It's a brilliant strategy. Just a quick side note, for those of you working in very strict corporate or enterprise environments, alternative tools do exist. Secure cloud browsers can completely isolate your browser session up in the cloud. They log and encrypt all your web activity, ensuring that the research is safe, compliant, and most importantly, doesn't introduce any malware risk to your organization's actual internal network. So, that brings us to the end of our blueprint. And I want to leave you with one final crucial question to think about. Is your current online research leaving behind digital traces that could contaminate your next big investigation? Honestly, if you're mixing your personal and professional browsing right now, the answer is almost certainly yes. It's time to rethink your OPSEC, embrace virtualization, and start building your own pristine OSINT lab today. Thanks so much for joining me on this explainer, and happy, safe investigating out there.